Hello, I want to welcome you to Locke High School. Kind of. I'm actually at home sick today, and my students asked me to try to make a video explaining the mean value theorem, so here it goes. What I would normally do to introduce the mean value theorem is I would actually talk about a function on a closed interval from A to B. And I would present a secant line on the closed interval from A to B, connecting f of A with f of B. The slope of that secant line would therefore be, using our old y2 minus y1 over x2 minus x1, would be f of B minus f of A all over B minus A. And my challenge would be to students, is there any points on the function, the red curve, where the slope of the tangent line on the red curve equals the slope of the secant line, cutting across from A to B? Now in this case, I tried to highlight two places where that happens. Once right here, and once right there. At those two places, it seems like the slope of the secant line is equal to the slope of the tangent line. So I would then challenge my students, can you draw me a function where this does not happen, where you connect f of A f of A with B f of B, and there is no point where the slope of the secant line equals the slope of the tangent line. One example would be here. So there's the closed interval from A to B. And if I actually were to place a secant line connecting A f of A and B f of B, my function, which is not continuous, ends up producing no tangent line that is parallel to that secant line. And if you notice, pretty much every tangent line from A all the way to B has a slope of 0. So there is no tangent line that is parallel to the secant line. So one way that you could get around this is by drawing a function that is not continuous. Here's another situation. Here's again a closed interval from A to B, and here is my secant line. And I'm going to try to draw a function that is continuous where there is no tangent line that is parallel to the secant line. And how do we do that? Well, another way to do it, we showed that you can do it as long as the function is not continuous, but we could also do it this way. The function is continuous, and if I actually place my secant line there, there is no point on that function that has a tangent line that is parallel to that secant line. So the other way we can get around it is by drawing a function that is not differentiable. So the mean value theorem says that if a function is continuous and it is differentiable, then there must be at least one point, we call it C, in between A and B where the tangent line is parallel to the secant line. In order for this to be true again, the function needs to be continuous and differentiable. The mean value theorem could fail if your function is not continuous or if your function is not differentiable. So if I were to draw an example like this, another continuous and differentiable function from A to B, there is one point in between where the tangent line slope is the same as the secant line. So let's place the secant line, and where would it be? The tangent line would be right about here. At that point, the tangent line is parallel to the secant line. Again, the mean value theorem does not tell us how to find that point. It just tells us that the point exists. So we would call that point in between, we would call that point C. My marker's not treating me right now. We would call that point C. Seems like it's a little blurry. The point where the tangent line is parallel to the secant line is called the point C. So the mean value theorem says this. Big if a function is continuous on the interval from A to B, on the closed interval from A to B, and if a function is differentiable on the open interval from a to b, meaning this will still apply even if it's not differentiable at the endpoints, then there must exist a c where the slope of the secant line equals the slope of the tangent line. You probably need to pause different parts of this mean value theorem so you can write them down. One more time. If a function is continuous on a to b and differentiable on a to b, again continuous on the closed interval and differentiable on the open interval, then there must exist a c where the slope of the tangent line equals the slope of the secant line. That is written in this way. Or f prime of c equals f of b minus f of a all over b minus a. Again, the mean value theorem doesn't help us find that point. It just tells us that there must be at least one point in between a and b where the slope of the tangent line, the left side, must equal the slope of the secant line, the right side.